All right. And we're back. So, hope everybody had a nice lunch. Now we're going to be back and talking about more front-end stuff, and specifically JavaScript running on the front end. So as we've alluded to all the whole last week, JavaScript runs on the front end. And so it's the language that all browsers understand. And so why might we use JavaScript on our websites? Does anybody have any reasons? Yeah. Yeah, it's faster. Yeah. Yeah, make some dynamic. So that's the huge one. It adds dynamism to your otherwise static websites. Because HTML, once it's loaded, it's just there. It sits there, and you can read it, you can scroll around, but there's no dynamism there. And so if we use JavaScript, we can start to add dynamism. And so that gives us access to the DOM and manipulating it. We can respond to user inputs. We can fetch information without reloading the page. And we can even run it when offline. We can also store information for later use. And so the conjunction of the last two allows things like Google Docs or Google Slides to be edited when you're offline. And so these applications are nearly limitless. You can do form validation stuff, autocomplete, animation, pop-ups, and really whatever you want. And so I thought, why not do a quick little demo on playing with JavaScript on the front end. And so say we're at this random page. It's the one, I forgot how to link a style sheet, so I had to look it up. And let's start playing with this page with JavaScript. And so the way you can start using JavaScript is right-click and use inspect element, or if you're using Firefox, it would be DevTools or something like that. And that opens a little page where we have a console. And so first of all, you see some errors, blocked by client. Random aside, does anybody know what this stuff is? Yeah, so it's actually my ad blocker in action. So you see stuff like secure pub ads.doubleclick.net, and error blocked by client is just my ad blocker running in the background and blocking these pages from being loaded. And so if anybody's wondering how an ad blocker works, it's actually via JavaScript. And so we can go ahead and clear this. And what do we want to do? We can delete everything from a website. We could do something like document, which is the entire HTML document. And if you remember from the DOM, it's our very highest level. .body, which is the part of the document that we see. .inner HTML will get us to like the HTML that includes the body. And we can just set it to whatever we want. We can set it to be blank, and it'll actually just wipe the page. Did we actually wipe the page from their server? No, it's just on our front end. So if we went and refreshed, then we're all back to where we started. We can go ahead and set document.body to equal hello world. And now it just says hello world. And so this is just a quick demo that we can do whatever we want with JavaScript on the front end. What else may we want to do? We can create lists. So let's go ahead and refresh the page again. We can do document.clear or console.clear. Gets rid of all of the, it just clears the console. And so maybe we would now want to create H1 that just says hello world rather than just having it in plain text. So we can go ahead and start just creating divs with JavaScript. So we can do var h, I guess, equals document.create element. What kind of element? Let's say it's an H1. And then we have now created an H1. So if we type H, it says we now have an empty H1 tag. Now let's fill that H1 tag with some text. So we can say h.inner HTML, just like body had an inner HTML tag or attribute. Every single DOM object has an inner HTML attribute. So we can go and fill that with hello world. And so how come the page is not displaying that tag that we created? Yeah, we haven't really done anything with it. All we did is created it. So it's now stored in the H variable, but we haven't put it on the page anywhere. And so the way we can do that is we could do document.body.append child if we want. and then give it h, and it will actually go and append it at the very bottom. Or we could just replace it. We could say document.body equals h. That won't work. Document.body.inner.html equals h. And now we have just this empty element. Anybody know why that happened? What does that sound? We're surrounded by water right now. But anybody see, it just says object HTML heading element. Why is it not actually working? Does anybody know? So we created an empty element, and it's a JavaScript object. And so when we try to, has anybody tried to console.log an object, or return an object, or print out an object in any way? A lot of times it doesn't do what you think it does. It'll just print out object within brackets. And so I think some of you yesterday had a problem with app.get and passing it something undefined, and you got that error message that said, error, it's looking for a callback, but I got object undefined. And that's because sometimes when you try to stringify objects, you get what looks like this, object and then the type of object. Does that make sense to anyone? Did that go over everyone's head? So when I tried to set the inner HTML of the body to h, which right now is just this object, it didn't work because it's an object and not like plain text like inner HTML is supposed to be. And so the way to do that would be to clear the inner HTML, and then to now append a child to it. And so just like we did before, document.body.append child h will now append the actual child, so that DOM element that we created, to the page. Yeah?
Could you just have done like document.body.innerHTML equals h.innerHTML?
No, because it would have set the what h.innerHTML actually was, which is just the plain text to that. So it would just say hello world, as if we just said document.body.innerHTML equals hello world. And so it wouldn't have been surrounded by h1 tags. And so this is just a demo. We'll get more into it in a little bit. But this is just the power of JavaScript. We can do whatever we want. We can even say like alert hello world, which will give us a pop-up. What happens if we did something like while true alert hello world? Now we're like back to the early 2000s when you would visit a sketchy website and just get spammed by pop-ups. And so we'll say, okay, oh, and this will go on endlessly. Thankfully, a lot of these browsers now say, all right, prevent this page from sending any more pop-ups, and it will just silence them. But that's how you could have like hacked your friend's computer back in the day. Just, you pest. So yeah, applications are limitless. Be careful with the alert and confirm pop-ups because you might start to annoy people. And so has anybody heard of this thing called Ajax? Everybody's favorite, right? The scary old Ajax. What does it mean? So it's asynchronous JavaScript and XML. What the heck does that mean? Does anybody know? What it means, it allows the sending and receiving of information without actually refreshing the page. Can anybody start to think of like how this could benefit us? One aside, it's a bit of an outdated name. XML is hardly used anymore. What do we use instead? JSON, exactly. And so Ajax can use a variety of formats. It can be JSON, it could be XML, HTML, even just plain text. What determines what kind of format that it uses? It depends. If you're requesting information, it's all up to the server that you're requesting from. Maybe they'll return JSON, maybe they'll return text. It just depends. For our own backend, it depends whether we used res.json or res.send. JSON will send JSON, send will send text. And if we're sending information, we get to decide. And it allows our front end to submit requests to our back end. And so this is the way that we're going to be talking between our front end and back end servers. So how do we actually use Ajax? Ajax is just a design pattern. It's not an actual implementation, but many implementations exist, including jQuery is probably the most popular one. jQuery.ajax or jQuery.getJSON are probably calls that you've used before. What are some other ones? Well, there's XML HTTP request, which is like the bare bones way to do it. It's built into every browser, and it's very tedious. And actually, jQuery takes advantage of XHRs in order to implement their own Ajax and getJSON calls. But what happens if you don't want to include the entirety of jQuery only to use their Ajax function? There's actually this new function called fetch, which is going to be part of every single browser API. It's not fully rolled out yet, but we'll see. They're going to make fetch happen. So our preferred method is to use fetch. Can we use it? So what does it look like? So here's our documentation. Notice this is experimental technology. It's not yet stabilized. Not every browser may not support it, but it's still the preferred way, and I'll show you why in a second. Can I use? Has anybody visited caniuse.com? Anybody heard of it? What it is it tells you, like, can I use this specific thing that I want to use in every browser? And so if you look at something like document object model range, it'll have it in every single browser. But with fetch, it looks like only about 63% of browsers would implement it. So why the heck am I telling you this is our preferred way to use it if only 63% of browsers can handle it? Because we have these things called polyfills. And so this link here is our first polyfill. Has anybody heard of what a polyfill is? So polyfill is a term that means I'm going to go ahead and implement something that's missing from your current workflow. And so just like fetch is missing from like 47% of browsers, this polyfill here, which was written by GitHub itself, so it's something that is very, very good. I would trust GitHub, the GitHub developers, that they were able to write this one function that I'm going to use. And what it does is it implements fetch for me. And so it says, this function is a promise-based mechanism for programmatically making web requests in a browser. This project is a polyfill that implements a subset of the standard specification, enough to make it a viable replacement for most uses. What that means in plain English is, hey, we know that a lot of browsers haven't implemented this function for you, so we're going to go ahead and do it. And so if we include this JavaScript file into all of our, into everything that we send, we can now use fetch wherever we want. And so that's what a polyfill is. And so maybe there are other cutting edge technologies that we want to use, like promises or like let something equal something else, like the JavaScript ES6 block scope keyword. That makes closures a lot easier. Maybe we want to use that. Maybe there's a polyfill somewhere that will allow us to use that in other places. So that's what a polyfill is. And so if we include this in all of our requests or results, we can then use fetch in our own scripts. And so fetch is promise-based, like it said on its GitHub page. It's a promise-based mechanism. And so what the heck is a promise? So we looked at promises a little bit earlier. Does anybody remember what they actually are?
So I think a promise is, I asked about this last week on one of the TFs, and it's like when you want something to happen once, but you're not sure when it's going to happen.
Yeah, on the right track.
Starting a server might be something that you put in a promise.
Yeah, on the right track.
Like you use it to prevent like that primitive deal callback.
Yeah, so
Like you say like
Yeah, so it fixes that callback hell that we were talking about earlier. So promises, what they do is they represent a value that may not be available yet. So just like a callback is a function that allows you to run a function once the function that you're running returns, promises allow you to just start coding as if you have that value already. And what that is just an alternative to callbacks. And so don't worry if you don't know how to create them, just know how to use them in a general sense. And so how the heck do we use them?
Why do we use this instead of callbacks?
It's just an alternative. It's the preferred alternative just because, as you've seen a little bit, code ends up being a lot neater. You don't have to error check in every single callback. You just do it once at the very end. And promises have 3 states. They're pending, meaning a value hasn't been returned. They're fulfilled, which means a value has been returned. And there's rejected, which means the operation has failed. So either it worked, it didn't work, or it still hasn't happened. And so what does this actually look like? Is everybody good on this slide? So here's the prototype. So we have promise.prototype with .then, which takes 2 arguments, onFulfilled and maybe onRejected, so 1 or 2. OnFulfilled is called when the project promise is fulfilled and pass the resolve value. And so what type is onFulfilled going to be if it's getting passed a value? A function, right? We're going to invoke it, pass it a value. So onFulfilled must be some sort of function. What happens if it's rejected? That's the second argument. OnRejected is called when the promise is rejected and is passed the error. And you may notice that the onRejected is optional. So we can just say promise.prototype.catch instead will catch the error, which takes a single function, onRejected, which is called when the promise is rejected and is passed that error. So very weird in theory. Let's look at actual code sample. Oh, and then returns a promise, and so you can chain them infinitely if you like. What does that mean? Let's look at an example. So we said we're using fetch, which returns a promise. And so we have fetch this web page, which is something that I threw up that just echoes the request back to you. So it's a debugging tool that I wrote. And so presumably this will eventually return a value. We don't know if it'll return instantly. Maybe I'm a horrible coder and this is very bad and it takes 10 minutes to return. But let's go ahead and just start writing the callback or the then clause as if we already have a value. So we can do .then is a function that takes a result. What does that function do? It returns res.json. So res.json, if you look into the documentation, is another promise, and that just converts the response into pure JSON, into a JavaScript object. Because if it's a very large request, it'll be streaming over, and you might not have the whole thing instantly. And so res.json means turn the response into the actual JSON. And so that is the then clause. But res.json is also a promise, and so we can invoke a .then on that as well. And so we'll take the result of res.json, which is just a JavaScript object, and what are we going to do? Let's say document.body.innerHTML gets the stringified version of that. And then that is our second then. Does that make sense to some people? It's a little bit weird because we start using these values just assuming that they've been returned. And so they won't actually, nothing will happen until we receive that return value. What happens if there's an error? We can do a .catch. If there's an error, just console log that error. I see some confused faces. Yeah.
So res is the result for the response from that website?
Yeah.
And is it the same? It's the same on each of those?
The first one's actually is a response object, and the second one is the JSON that res.json returns. And if either of them error, then this catch will get invoked. Yeah.
Can you remind us what, just like a regular XHR call or just like a jQuery.ajax call would take to like put this in context?
Yeah. So fetch and XHRs and jQuery.ajax is you just give it a URL and some sort of request method, which will default to a GET. And so this is just making a GET request to that URL. And we'll return like HTML if it's just an HTML page, or if it's JSON, it'll return that JSON. It'll return a request object, and then this .json is like a parser thing. So I see a lot of confused faces. Would it help if I wrote this as if it were callbacks, and then also showed you a promise-based implementation so that you see what are the differences? Yeah? All right, so let's do this. All right, so over on the promise side, we have fetch something. This call, which returns a promise. And then we can say when the promise is fulfilled, then it takes a function, and we can just call it the response. And what does it do with the response? Well, the response is this weird response object, so we can actually just look into the documentation. And what it does is it returns a response object, which has on it a bunch of these things. So a status text, response.ok, and then some body data, which we can get at by using one of these functions. We're going to want to use .json over here, which will extract that body from the request. And so we can say what we want to do when we get that response is return response.json, meaning extract the JSON from that request and return it. That itself returns another promise. And so we could say, then when that's done, we want to use that. So function, say we get JSON back. We want to use that JSON and populate the page with it. So we could say document.body.innerHTML. So just like we were doing before in the demonstration, equals that JSON. And that's all there is to it. Of course, we want to add some error checking. So if we do .catch, so if it did error, pass me that error, and return, or just console log that error. And that's a complete implementation using promises. So what would it look like if we were using callbacks? It would be fetch that URL, and presumably we'd also pass a callback that gets invoked when it's done. So function, they usually have an error and a result. And then if there's an error, then return console.log that error. So do you see how line 2 is almost exactly the same as line 7 through 9? If an error occurs, just console log it. And then what do we want to do with that result? Well, we want to do result dot extract JSON, which isn't actually a call, but we can say assume it is, which takes a callback, which will presumably be a function that takes an error and passes the JSON back. And then if there's an error, we want to return console.log that error. And if we do get JSON back, what are we going to do? We're going to update that document with that. So document.body.inner HTML equals JSON. Close that, and there we go. So do you notice how the fetch is, I would argue, is neater, especially if we wanted to do something else with that JSON. And if we started chaining these, if you see on the right over here, we're going to get this Christmas tree of doom. It's called callback hell. And every single time we invoke another callback, we need to check if there's an error. Whereas on the right, we just say, hey, if any of these error, this catch function will catch it. Yeah.
That means you'll have the same catch for every single error, even if they're different types.
Correct. So errors, this error is always going to be type error. And so you can just do with it whatever you want. You can console log it. You can say, oh, we're boarding, and actually redirect the window. You can flash an alert message that says, oh, sorry, we errored. Any of the above. Yeah.
Could you also, I just kind of am confused by why you have like the two .then methods.
Mm-hmm. Yeah.
Is that just because you wanted them to be like asynchronous?
Yeah, so that confused me a lot. So what happens is response.json is also an asynchronous call. Because say projects.jordanhayashi.com/echo actually returned a 5 GB file. You're not going to have that instantly. You're going to have the response immediately, and then it's going to start streaming a bunch of stuff to you. And so you don't know. So even though we have that response and we're starting to work with the response already, we're still getting streamed the actual body. And so what this does is it will extract that body into its JSON and then let you know, hey, we're done streaming it. Here's that value. And so this is also a promise, which means we could have done this. If we wanted to. So that's exactly the same. So response.json is a promise. And we could have just stuck a .then on that immediately. But we're starting to look like callbacks again, which is why we would prefer to return it and then have a chaining .then like this. Is anybody very confused and has no idea what's going on? Because I can explain it in other ways. Yeah.
So when you say like there's no value yet, and it's like a replacement for a callback, so that's the .then doesn't run until the function it's attached to returns a value.
Exactly. And so that's the whole point of a promise. It means, all right, I'm making a promise that I'm going to do this eventually. And when is eventually? As soon as you get returned a value. And if it fails, then immediately just run to this catch. Because a promise only has 3 states. It's either unfulfilled, so it's just pending. It hasn't been like fulfilled yet. It is fulfilled, which means it's been fulfilled with a value, and the value gets passed back. Or it was rejected, which means there was an error. And so, yeah.
So in the example you were trying before with the 5 GB file, when it was returning like part of the file, the second then statement is still running even though the full value hasn't been returned.
So this first function has the response has been received.
Okay. So even though like it's only part of the whole 5 GB thing, you're still.
So the beginning of the response was received, but the entire body hasn't been streamed back to us yet. Okay. And so this response.json call means just take that body, combine it into whatever it needs to be, and then return that to the next function.
So it only returns it to the user, or it only returns it to the function after the entire thing has been.
Correct.
Streamed. Okay.
If you agreed with me, I don't really like this response.json thing, but it's necessary because of the asynchronous nature. Otherwise, we'd just be halting and waiting for that entire response to come back. Yeah.
Can you like provide like a timeline of what's going on, like the minute we send this request, and kind of like when is the next .then method like invoked?
Okay. I'll see if I can do that visually using the browser. Were there any other questions, Johan?
Why are you using like fetch on the right-hand side just as like a demonstration?
Yeah, it's just as a demonstration. So on the right-hand side, this is just an analogous call. Fetch, you can't use fetch with callbacks, and extract JSON is not an actual function. But this is kind of the analogy if we were to use callbacks, this is how it would look.
Would this be really different from just using like app.get or something like that?
So this is now front-end JavaScript. This is running within a browser. And so we could do this. So let's just use this can I use page. And if I did right-click, inspect, and then started typing at the console, if I did fetch from, this is exactly what I just typed, fetch project.jordanhayashi.com/echo, then take the result and do res.json, then take the result and do document.body.inner.html gets the stringified version, .catch error gets console.log error. So this is exactly what we typed here. If I run this, now you see that the body got converted into the response JSON from my website, which is just is echoing the request back to you. So you see host is project.jordanhayashi.com. There's no parameters, there's no query, there's no body, there are no cookies. Method is get, URL is /echo. So this is all stuff from Express. And so if you want to look at the sources, yeah, I don't know if there's that visual way I can show you. But essentially what happened was we fired off that fetch request. And say if this is a timeline, maybe that happened here. And that got sent over to my server. And meanwhile, this promise says, whenever you get the response, do this. Whenever you get that response, do this. And if it errors, do this. And so that's all stored in memory. And so now say we have a response. So there's a response from the server, and what happens with that response? It gets plugged into that function. So now we have a function that takes this response and runs res.json. And so that's the next one, which happens like immediately after that. And so maybe this was streaming. This is done. And so now we have the body and is turned into JSON. And so now what happens? We take that JSON and we replace document.body.inner.html with that. So that happens here. And that happens like there. And then catch never does anything because there were no errors. Does that make sense?
So then what's the asynchronous part about this?
The asynchronous part?
Yeah, how is this better than doing it synchronously?
Because if we were doing it synchronously, then everything would halt until this page returned. So it's just like the example from yesterday or a couple of days ago, where it's like you want to hang out with your friend has something to do, and you don't want to just sit there waiting. You want to do other things while your friend finishes his piece set. And so this is the same asynchronous thing. So doing promises and callbacks are nearly the same exact thing. This is just becoming the new way to do it. And pretty soon, all APIs will be returning promises. And so it's important to know how to use them. You probably will never have to create one yourself, because all APIs will just return it for you, and you just need to know how to use the promise. Does that kind of make sense to people? You'll see this structure quite often every time you make a fetch call. Okay? All right, so let's try to start using these things. And so over the last week, what we did was build out our back end, right? And so this week, we're moving on to our front end. And I had a great question over Hack Time where it was, like, what's the difference between our API server and our front-end server? How do they communicate? Like, what's up with having these two servers? And essentially what we're doing is we are creating our front-end server, back-end, database. So essentially we have this. We have our back-end server, which communicates a lot with our database, right? We have our front-end server, which communicates with our client. That's a computer. And so we have these two kind of disjoint things. Right now they're disjoint. They're completely different servers. And pretty soon we'll have them start communicating with each other. And so why have two servers at all? And this is kind of MVC a little bit. So this control has a lot of our models. This, you could say, is our controller and our views. But the biggest reason was because we might have something like this. Oh man. That is a phone. That may connect to like here, or it may connect to here directly. And so because we have this separate backend, we could have other clients like our phones, or this is an iPhone, that talks directly to our backend, whereas our front end is what interfaces with people's web clients. And so these are two completely different servers. Like one might be running at localhost 3000, one might be running at localhost 3001, and they may talk to each other at length. But ultimately what the client actually talks to is the front end, which talks to our back end. Yeah?
Can you give a case where a user is like accessing or like talking to the back end without talking to the front end? I don't really understand that.
So it's possible that we want to talk directly to the back end. So say our front end, say on our website over here, it has a fetch call. All of our users. It's possible that that will grab straight from the back end, which would return to here. Generally, sometimes that's considered bad practice, and I'll teach what's called reverse proxy, where it actually gets sent to the front end, which then says, all right, I will send it to the back end, receive what the back end says, and forward it to you. That way, a user will never know where a back end is. For all they know, it doesn't exist. And so a reverse proxy would be a way to kind of hide the back end from the end user. Yeah?
So what is your web server?
So web server is something that serves up web pages, generally HTML, which is, I use it interchangeably with the front end server. And so it's just, all it is a program or maybe like an actual computer that receives requests and returns the HTML pages. And so that's generally just a front-end server or web server. A back-end is also a web server because it's a server running on the web, and it just serves up JSON or just pure data. And so the difference here is the back-end will serve up pure raw data, and the front-end will serve actual completed views. And so that's where that view engine and HTML comes in, CSS. Yeah?
How is the like fetch /users related to like app.get /users?
So app.get is a route that we define on our backend. So our backend and all of our servers are listening for specific endpoints. And that's what app.get is. It's an express specific call that is listening for that endpoint on that server. Fetch users means visit one of these servers. So this would be fetch localhost 3000 /users. And so localhost 3000 is the address for this server. And then say, hey, I want your endpoint /users. What method? I want that get method. And so this would be fetch localhost 3000 /users. And this via app.get will be listening for requests on /users. Yeah?
Is the backend web server like Express?
Yeah, so these are both running Express. So the way we create servers that will listen on a specific port is using Express. Yeah.
What kind of things do like Amazon Web Services, like what can they provide in terms of, just because I was trying to, over the weekend I was trying to like figure out like there's a guide that said you can build an API using Amazon Web Services. Do you have to know like what to replace in terms of these kind of things?
So where does AWS fall into this? So what you can do is you can say host this on AWS. So this server is running on AWS. So rather than it being your physical computer, which is serving up those pages, it can be a cloud server. You can have this run from within an AWS instance. And you can have this run from within an AWS instance. You can also use any hosting provider that allows you to run nodes, so Heroku or Rackspace or Azure or any of those. You could also have them all on one large AWS instance, and so wrap that all in one big square that's running on AWS. Right now that's synonymous to what we're doing. You can wrap this all in one big square and say it's my computer. Does that answer your question?
Yeah. So it's kind of like, it just provides like servers or like memory, or like what's the benefit of using the AWS?
It exposes it to the world.
Oh, okay.
So what we're doing right now is we're writing software that starts up these servers, that creates these virtual servers. And we need an actual server to run these virtual servers. And so AWS gives you an actual server that allows you to run the virtual servers. And so there are other things like Heroku and Azure Rackspace. They all also give you server space that allows you to run these things. They give you your own server. Yeah.
Yeah, so like right now when you do it, it's all localhost, but someone else can access your website at all. When you put it on AWS or a different server, anyone can go on. Can you compare host?
So if I were like, hey, I don't want to pay for AWS, I just want to be able, I want the world to be able to access my website from my own computer. You could absolutely do that. You would have to just plug in your computer to the worldwide internet. You actually have to have a public IP address, so some sort of address for people to find your computer. And then they would just say, hey, visit this IP address at port 3000. Or you could change it to port 80, which is the default port for HTTP, and people would be able to grab websites from your servers that way. Yeah?
Can you refer to like the actual server? Is that like the hardware server? Like what's the difference between like the server you write and code and like the hardware that is actually being used at AWS or some other computer?
Yeah, so it's a little bit ambiguous because we use this word server everywhere. There's something called a bare metal server, which is the actual hardware that is the server. There's a virtual server, which acts like it's an actual server. There's a server that's running on your computer, which is another type of virtual server, which is server software that acts as if it's a server, which is run by Express. So it's very confusing, and I can see why people are confused. Would it help if I used the terms metal if I were talking to about the metal servers versus program if I were talking about the server that's the program that's running? Okay, I'll start to use those terms instead. So these are all programs that are running that are listening for specific endpoints at specific ports where the address is the address is the location of the metal. And so when you say google.com, where's google.com? Well, google.com is located at 172.217.1.78. That is the address, the IP address of the metal that is Google. Within the metal, there are programs that are running that are listening for requests to slash on port 80, where port 80 is the defined port for HTTP. That's just the standard for the internet. And so if we say, hey, submit a request to that metal will say, hey, by the way, the program that's running within me, we have a request /. And that program says, all right, I should serve this page. And so Express is the program. We can think of Express as a program that's running on Google that says, all right, I have a request /. Let me return this HTML. And so it returns it, and so it gets sent to the user. And so you can think of the metal as what the program is running on. Does it help at all if I say metal and program rather than server and virtual server and web server and front-end server and back-end server? I'll start to use those terms. But just once you're comfortable with all of like what's actually going on, start to use the term server so that other CS people will understand. Because if you said, hey, like, what metal are you running on? They'd be like, metal? So, does that help? Are people starting to understand what's going on? So right now, within our metal, which is our laptops, we have multiple programs running. So we have a program for our DB. We have a program for our back-end program. And we have a program for our front-end. What are these programs called? Well, the DB is Mongo. Backend is Express, and it's that Express file that we wrote. The front end is also written in Express, but it's a different program that's running on our computer. And everything is running on the same metal, which is my laptop or your laptop. Does that make sense? Yeah.
How does like file transfer protocol fit into this?
So how does file transfer protocol fit into this? It's your computer listening on port 22 rather than listening on port 80, which is HTTP. And FTP is just a way to send files back and forth. The way we choose to send files back and forth to a computer, rather than saying, hey, when I want to push my program to this actual metal, I can use FTP, or I can just say git push, and it will take care of that for me. And so git is another way to send files back and forth, rather than using something like FTP. Is this starting to become more clear to people? Do people still have questions about all this, any of this stuff? Yeah.
So just so I can get like oriented for the back end in terms of like the code you wrote.
Mm-hmm.
Like so we usually have like a few files. Like we have something that we've been storing in like the main folder.
Mm-hmm.
We had like coupon.api.js, right? That's and all the stuff we did like last week was all the back end stuff.
Mm-hmm. Exactly.
And the stuff we're doing today is all the front end stuff.
Mm-hmm.
Okay.
So what we've been doing today and what we've been doing yesterday, you can think of it as like folders on your computer. Like if you imagine the tree, we have like coupon-api.js and then like app, or that's like models, controllers, like etc. So if you recall all those files work together to start to run this program called the backend program server. We also have a bunch of files over here which we call coupon frontend.js, and we have app, which has within it views and JS and style sheets and stuff like that. And those files work together to create this program that runs. And so right now we have these two programs both running within the same metal and with our database all in the same metal. And if you expect a lot of throughput, you might then split them up to different metal. Yeah.
So the program is running on either backend or front-end server, which is literally just like coupon-api.js, like in a terminal, like in a more literal sense.
Yeah. So just like you run like node coupon api.js and it starts to run in a terminal window, that's all that's happening on these big expensive servers that Google has. Like you are now doing what like people in industry actually do. They might have things listen that like, hey, if it crashes, restart it. But for the most part, we're doing what the big guys do. And we're only on day 5. Yeah. next week we'll all be working for the NSA, and then. But yeah, so don't be worried if you're a little confused. We have been moving extremely fast, but if you're confused at all, just let me know and I'll try to clear up any confusion. But a lot of it just comes with working with it, I see how this is working just by coding. But anything conceptual, please ask. I am more than happy to answer. Don't make me just ask you. So is everybody clear about how this works? Yeah.
Can you specify one more time like how you're, like for example in the directory we're working into, like we'll separate into backend and front end?
Yeah, so right now, let me just... So right now, within my computer, I have this directory called coupon frontend and this directory called coupon API. And I can say, within coupon API, I have these controllers, couponapi.js, package.json, all these files that we've been working with. In coupon frontend, we have app, grunt file, package.json, coupon frontend.js. And so the most important files right now are this coupon API.js and coupon frontend.js. And they're two different files on my computer. And when run, they will create their own, they will start running this program. These programs are different because one is listening on port 3000, one is listening on port 3001, this one's listening on port 5000, arbitrary numbers for now, well, arbitrary numbers in general. And so that's how you interact with each of them separately. You can say, hey, I only want to talk to my DB at localhost 5000. But why should I try to talk to my DB using my DB's language when we have our backend coded specifically to talk to the DB? So rather than talking to the DB directly, I'm just going to say, hey, localhost 3000, which is this program, the backend program, you do your thing with your DB and just let me know what it returns, because I don't want to talk to the DB directly. And then why even work with the API at all? The API is probably complicated. So why not just use the front end, which is at localhost 3001, and say, hey, fetch me the index page, which will then go and grab all of the coupons or go and grab whatever from the database, return that to the back end, return that to the front end, embed that into a view, and then show me the nice and pretty view. And so that's the whole point of like this chart, is that we never directly talk to the DB. Our backend code does that for us. Only if we want to work with raw data do we ever work directly with the backend. Otherwise, we might as well work with the front end, which we're going to code, such that it works with the data and presents it very nicely to us. And so that's kind of the whole point of MVC, is the down and dirty models are just raw data. But I don't want to work with raw data. I want to see it nicely. And so that's what the views do. They make it look nice for us. And so how do I now interact with things is through the controllers, which translates what I want to do into logic, which gets applied to the models, which then refreshes the views that I then see. And so MVC is everywhere, right? MVC. Oh, Illuminati. Oh, right? It's everywhere. But are there any questions about like how this works? Is it starting to clear up in your head a little bit? All right. So how about we start looking at front-end code and see if that starts to help us make sense of these things. So I've used Git, everybody's favorite program, to push this new coupon front-end file. So if you all want to git pull, you'll have all this coupon front-end code that I've pre-written. Are people still having issues with Git conflicts, or are you all a little comfortable resolving them? I see some nodding heads. Look how far we've come, guys. Fixing Git conflicts. So first thing you want to do, you want to git pull, fix your conflicts, cd into coupon-frontend, And then we start to see this directory structure that we've been working with so far. So there are a few more files than our practice exercise from last hack session, but it's set up very similarly to, So we have our coupon frontend.js, which is here. In the root folder, that's just our express file. We have gruntfile.js. We should all be comfortable with grunt files. Package.json, something we've been working with for a while. Then we have our app. Within it, we have a script, or a JS folder with a script. We have a models folder with our config. We have a views file with a couple things, our template pug and our index pug. And then we have public, which is fetch.js. Fetch.js, what is that? Can anybody guess? It's that polyfill that I showed you guys earlier. And so by sending fetch.js with all of our templates, that allows us to use fetch on the front end without worrying about any cross-browser issues. Script.min.js is probably what? Will? Is Will in here? I'm cold calling you. What is script.min.js? Oh, you weren't here this morning, were you? Okay. Raj, what is script.min.js?
It's probably something that either compacts or extracts the JavaScript because we like use a Wii5 or whatever to make it like concise.
Exactly. So it's the minified version of this script file up here that was run through Grunt, which uglified it, minified it, into script.min.js, which now lives in public. And what is special about everything within that public directory? Yeah.
It's what the users interact with.
Yeah, users, anybody on the internet can now grab any of those files. And so you better make sure that these files are what you want them to show. You should never put like your coupon frontend.js within your public. Otherwise, everybody could just steal your code and now they can go start a competing company. And style.css is that compiled style.style from up there. We now have this new thing called routes, which is a new file. And that's just me saying, hey, rather than listing all of our routes within our Express file, I'm going to abstract it out. That way, I don't have this super long file. And so what this looks like is we have this new call that we haven't seen before, which is const routes gets route/index. So that's probably saying this route/index file is going to module.export something that we can import into here. And then we have app.use/ gets routes. So what's app.use/ routes mean? What kind of function is it? It rhymes with Gittleware. It's middleware, right? So every single time we have a request on /, we're going to dispatch that to routes. And so what is routes? Well, it is this. So we have const express gets express. We've seen that before. This new thing that's const router gets express.router, which is just saying rather than using app.get, I'm going to use router.get. It has almost all the same functionality. And then, of course, requiring config. And now you just see something you've seen before many times is router.get/ is function this. So something we see all the time. And then module.exports gets the router. So every single route that we define here, we're going to export it, which can then be imported into Express. Yeah?
So router is a function on, like it's part of Express.
So if we just look into Express, router, then you can see that this creates modular mountable route handlers. Why? Just because we're separating out our logic a little bit. We don't want a super, super long file that gets a little hard to maintain. Yeah?
Why did you, in that index file, choose to assign the router that you defined to the module.exports as opposed to add it as another method?
That way we don't have to do module.exports.get, we can just say router.get. So it just makes it a little less typing. So the question for the mic is, why aren't we just doing this module.exports.some method rather than this? And my answer was, it's just easier to type. And it's easier to scan through. You don't want to see module exports everywhere. Router.get just makes a lot more sense, at least to me. Yeah?
The only use of this is just to put it into a different file.
Yeah. And so maybe we have a bunch of /users something. We can split that into its own router and say app.use/users gets this separate router file than /items or /coupons or something like that. So it's just showing you guys how to start splitting up your file so things are more maintainable and more modular. Does that make sense? So we kind of know everything thus far. Is anybody clear about anything that they see here? It's almost exactly what you worked on in your last project. Or I mean in the last hack session. Actually, I did get a request. So what exactly happens when you say res.render this page? So what's the order of execution in there? And so so what actually happens when we say return res.render partners pass it students paired? Why can we use students there, but we can't use students on the client side?